Okay, so now you should see it again. So let's start again from the beginning. So as I said, we divided the course like we described we decided in Leiden for the distributed system, which is an elective course. We divided the course in 3 parts, 3 chapters basically, 3 main units. One is a distributed system in general, another is a cloud computing, and another one is on blockchain. And the idea was also to have some lab together with a session on the session that on presentation and teaching. And the labs was only about blockchain. So there is a lab that it will be taking place at the end or during the part of when the blockchain starts. So, and for the rest, we have some exercise, and there can be also some extra exercise that can be put there. We discuss this in a moment. So about the distributed system. So let's go just by lecture. So we prepare some set of slides that are actually coming from Yuso Kangashiro from Helsinki University. And he has a course, it's a small course on a distributed system, which is based on the book of Tannenbaum and Martin van Steen from the Free University. The Free University is they are colleague of us from the Netherlands, so I know both. And so they suggested to have this set of slides for working for their book. So at the beginning, we start with some notion of what is a distributed system, what does it mean distributed, the difference also between concurrency and distribution in general. And then it moves on protocol of communication between different nodes of the distributed system. And here is just the standard protocols that are presented. And then on the third lecture, we move to what is the synchronization. So what does it mean synchronization? So there are all these processes which works on different nodes in the systems. They go all to different speeds. And from time to time, they have to synchronize, and there are several algorithms how to guarantee that synchronization happen. And so those algorithms are studied during this lecture. This lecture is quite heavy in the sense it's a long lecture. There are a lot of algorithms. And maybe you already know that when you teach algorithmic things, so the algorithm takes time to be digested and to teach. So it's here really one, and you cannot just do. I don't think it's possible to do all these set of slides in one single lecture. So this should be more distributed in at least 2 lectures. Then we go to typical problems that there are in distributed systems. So one is once you have data which is distributed in different nodes, how do you guarantee replication? Because it costs time to copy data from one node to another. And now you have consistency of data. So when some queries are asked to virtually, then the right node should send the right answer. So the consistency problem. Also there are some algorithms presented here. And then the other problem of distributed system, which is fault tolerance. Yeah, okay, so if some node fails, this is what can you do in this case, and duplication and things like this. But of course, duplication brings also other problems. So how you cope with all this? Then there is another set of slides, which is also rather extensive, which is the slides on security. So security is, so it's about more on cryptography and keys and all this. This could be a point which, for example, one could also try to not to mention. I mean, one can also mention that there is security, but depending on the time, depending on the time that is needed, that this could be one lecture which it could be easily skipped because it's not related to the others. So that could be very easily done. Then we have, at this point, this would be a good point to give exercise on that. Maybe I can show you some of the exercises so that you have an idea of what they are. They are all exercises on this previous section that we have seen it. So let's just me share that file. 1 second, and I take this file. That's here. So let's find where is it. Yeah. So these are exercises. So the first things are on the first lecture. So what is a distributed system? And then you have, there are 3 different questions which can be done in class or can be taken at home, for example. And they are like, what is a DNS server? How does it work? And a single DNS. The second is about remote procedure call, transparency, but it's related to the second lecture. And so about protocol of communications. So in a distributed system. And the third is about synchronization. So remember, it was about synchronization, the lectures. So there are some questions that are related to how to synchronize, for example, the different systems. And as I said, this is quite an extensive lecture. So there is also synchronization, I see from Lamport clocks. So using different notion also of time and how does it work, synchronization with time, and what is time in a distributed system. So if it is soft or hard and things like that. Then there are 4th set of exercises, also questions, which is about the replication transaction, the failures, and so on. And okay, here there are basically not too complicated questions, but just they are good for realizing if the students are on track with the study. And then okay, we have the fault tolerance exercises, and some other algorithm on phase commit, 2-phase commit, and let me see what else. Yeah, so that's basically all. So we have 6 exercises on a different lecture that can be used at when one wants. So immediately after the lecture, if one wanted, or just before that, just at the end of all this set of lecture. So maybe I can, I don't know if you have any questions. Because otherwise, yes, sure.
I have a look into the materials, but for the materials for the security, when I open the slides, the content is not the same. I think the content is not about security, it's different.
Yes, wait a moment. Let me just see. Maybe I don't know now. So let's just try and see. Let me just open. Let's just open the first material. So security is security distributed system. Yeah, 6 say. Yeah. Oh, that's indeed. I see. This. There is a mistake. Yeah, that's a mistake. So they've been in the uploading, and then there has been a mistake, and I will try to repair that. Sorry, let me write this down. Yes, this is completely different. Yeah. So it's the lecture 6, section 6. So I will on security. Distributed system. Okay, thanks. Thanks, you pointed out. That's indeed. It's completely different. Let me just check that if the other, if this is the other way around, that if you take distributed coordination system, there are some problem with the names, I see. Distributed web base. I will check the name because this is also wrong. Okay, so that's I will check those names.
The other is also wrong. Is it the number
The
14?
lecture 9. Oh yeah, security is here. I found it. Security. Okay, I found it. If you give me 1 second. Okay, the security is here on what is called distributed system 8.
Oh,
That's the
yeah,
security.
I found it as well. Yes.
Yes. So is there? So it's only the name for some strange reason. They are completely wrong.
I
So
can just rename it on my copy.
so but I will rename in the share space. So that's so we are talking about year 6, 9, and 8. So there is a circular things between these three names. Okay, so the slides are there, but they are wrong. Okay, thanks for pointing out. Yes. Any? So if you do you want me to share the security slides?
I already have a look. I mean, it's number 8, and actually in.
Yes. If you just take distributed system 8, then it's
yes,
that's the security part. Okay, so let me go then back to the overview, which up to some renaming, then there is, let's go back to share the overview. Yes. Okay, so we were here to the security and the exercise. So the name again, please apologize for that because it's indeed completely wrong. But the files are there, and I will substitute immediately after the meeting. Then we have a lecture, this time from directly from Martin van Steen on distributed file systems, and that basically was the distributed file system and the content and software defined network was what was required in the description. But we think that if one has time, or then one could also try to handle, for example, things like distributed coordination system and distributed web system, web-based system. So this could be optional set of slides. So the 8 and 9 are optional, but that can be treated. They are not very complicated, and they just give more information. For example, on the coordination system is about how it works, how different systems can coordinate to shared data space. There are languages like Linda or Linda-based, for example, that are that work with system. The work, the coordination, the synchronization also happen all through shared data space. Then we go on the new way of seeing networks. So the computer networks we're talking here, and there is the content delivery networks. That's actually there is not much to say about what content delivery networks are. So there is only what is the definition of what they are and how they work. And there is much more to be said about software-defined network, so the relatively new concept on how to directly program the computer network, instead of really working with the switch and hubs, and directly you can do programming at the level of the network. So these are relatively, especially software-defined network is a relatively recent topic, and it's quite interesting. And yeah, especially in the world of distributed system, this is one of the big changes in that recently has been taken place. And yeah, it's getting more and more increasing popularity. Okay, so that's all about general distributed system, and from here then we move to cloud computing. So cloud computing, first, yeah, they try to give an introduction of what is cloud computing in general. So here we use the slides from one of our teachers, Chris Rietveld from Leiden University. And we just try to define what is, and especially there is important concept are the concepts that are described below. So that is the virtualization, the fact that you have virtual services are important, and also the difference between virtualization and containers in general. So, yes. Was it a question? No. Okay, so here we go to the difference between virtualization and containers. So what is a container? So what is the difference between, for example, VMware or Docker in terms of technology, and how these things works, and why, and the reason why people introduced these concepts. Then the three main models of services, the SaaS, IaaS, and PaaS. So the process service, I don't remember now the acronym. But so we talk about these three models, the difference within them, and then from there we build on technically what is that makes cloud computing a success story. Then there are more advanced topics that could be skipped. So these two set of slides afterwards, there are slides that could be skipped if one wants. One is more on the how to orchestrate several containers. So it's how to coordinate. This is related to the coordination that we have in distributed system. Here is the coordination between different or the different containers and different container system. Also, you have the problem, also the interoperability problem between the different vendors of containers. And finally, there is some very light slides on recent trends on cloud computing. That I must say, there is not very much to be said. That is the cloud computing is going to be more and more in popular, and on top of the service model, there will be also the business as service models on top of it. So that's basically all about cloud computing, because it's just building on top of the distributed system. So the main work is done at the level of distributed system, and then once the students understand especially how it works for the first, let's say 5-6 lessons, how it works and the distributed system. So the main point are the distributed file system and this one, security, if one has time. If one understands this, then understanding cloud computing is relatively easy. So then we go to the final part, that is the part on the blockchain. For the blockchain, there is we use the slide of a course from Edinburgh University, presented by Argelos Kiaias from Edinburgh University and collaborators. And they have a very nice way of presenting the course. So first they introduce what the blockchains are, what is the data structure of blockchain. So these are the basic lectures that everyone needs to have it, and then you move to to the different aspects which are related to blockchain. The first two are necessary, especially for creating the first two, and also this one, the security and the smart contract, is necessary for doing the lab projects. So the lab project can only take place after, only start after the lesson, the 5 lessons on blockchain. Could start earlier, but it means only that that you could start just by putting some information on how to work with the blockchain. Here is important also to mention that the labs that each university has, that they have to install their own private blockchain framework. And one possibility is that is also suggested by the slides, is to use Ethereum. So Ethereum is maybe known because of the one of the most successful crypto money, but it's also possible to install without cost to install it in your own labs and play with it. Let play the students with it without in a closed environment, let's say. So that's why the one, yeah, every partner here in the project should install their own blockchain framework. If not Ethereum, you can also use other one. The project can be adapted to that. But at the moment, the project is based on Ethereum. And how to use it and how to work, well, that depends from different implementation. That's why we have left this open for the moment. Yeah, so then after let's say what is a smart contract here on lesson 4, and what is how to find the consensus in a blockchain. Yeah, there are other aspects that are aspects like the economics aspect, the different protocols which are presented there, what is anonymity and privacy and as guaranteed in blockchain. And so forth. So these are a topic that one, of course, it would be good to treat it depending on time. So we put all the material there and also on a possible application for it. I think that for the students, the most important part is that they really have to put hands on this. They really have to work with on the labs with the blockchain, and that's why it's important that every partner install its own blockchain framework inside their own labs, so to create a distributed system with the blockchain. Maybe we can just see a moment the project. So let's just try to open this. Let's share it. Where is it? Yes. Okay, so I'm trying to move it to no. Okay, so here is basically okay, you see this is from Aggelos Kiayas, and yeah, the idea is about the development of some smart contract, and yeah, there are two different way, but it's based on the implementation that they have here, the private Ethereum blockchain in Edinburgh. So they make no sense to click. Yeah, you can click there and go to how this work for the instruction how to use it, the blockchain for Ethereum in Edinburgh. But first you have to see if those instructions are complying with the implementation that you're using in your labs. So be careful in using this, that you don't just cut and paste the file by then having links which bring somewhere else, which doesn't work. Okay, so that's basically what the students have to implement these two parts. They have this implement or play with this project. The one is called Cookie Monster, the Mora game, which are here, and they are all based on this this Ethereum network, blockchain network. Yeah, okay, so that's how it works. What can I say more? Yeah. I think, yeah, well, that's I think that's yeah, one has to study and then to look at it more deeply. It makes no sense to discuss this at the moment. So let's just go back to the material. I don't know if you have any questions.
Actually, what I'm thinking is I didn't see anything about game theory here because we use that a lot in the consensus process. So should we add that to the core course or should we just put it here?
So, well, because if you go game theory is, okay, it's quite a topic. That's, I don't think, I mean, having a game theory there, it would be, okay, let's put it, if I would do game theory, I would put a full course on game theory. And okay. with application, then for example, try to find the consensus. Then as application would be that. But to have it the other way around, that we have here how to find the consensus, and then one has to do game theory for that, I think that's too heavy for the students.
Okay.
So I don't think we have any other place. Game theory doesn't come in any other place in our program. So that's yeah, okay. It's not really artificial intelligence, or it depends how do you see, of course, what is the definition of artificial intelligence, but it's not really artificial intelligence. So it's a more an algorithmic aspect how to solve a problem in this case.
And that course is really, well, really big already. Like there's a lot of things in there.
Yes, but game theory there is a lot of things. Yes, I think that the most close, not really to game theory, but it will go maybe courses like MODA, the multi-object optimization and decision analysis course. They will use something to try to find the balance, not the best, not the perfect, but not the perfect consensus, but just try to find an approximation to the best. You know, trying to optimize the system. You can see also as an optimization problem, maybe. But no, I don't, at the moment, I don't think, I think that this will be too much. It's already too much. The material, if you think, the material is already too much.
It's a lot for one course already.
Exactly. If you think typically, I think one course will cover only distributed system or distributed system and cloud computing and blockchain apart. We have 3 different things in one single course. I mean, more would be too much, I think. So, but don't understand me wrong. I'm not saying that we should not do it. So if you try a way to find a way to do it, please. I think it's actually very important. Yeah.
In our case, in my university, currently we have the course similar like topic number 1, only distributed systems, with the same textbook as well from Tannenbaum and Martin van Steen. And the same set of slides. I mean, it's similar from the books, right? I mean,
exactly. So that's why, and your course is 3 credits
for undergrad, but for undergrad it's 3 credits, but we combine it with parallel computing. So half the semester for distributed systems and half semester for introducing OpenMP, MPI, etc.
I think
we have another.
Sorry, if I just
we have another course for cloud. Okay. Yeah.
No, comment just before. Then I give you a word to you. Just before you go to the next topic, because I think because this is a master course, it was decided on purpose to try to avoid to have parallel programming. So to teach the students to learn the students parallel programming, because this would really takes too much time to have lab session on. Parallel programming or high performance computing, even that would be too much. So that's why distributed system, maybe the content is similar to what a bachelor is, but it's more here seen in terms of slides, but not of labs. So the students will not put hands on that, because they are maybe supposed already to know a bit of this.
And for the cloud computing, we have also another course for undergrad. The content is similar, but I mean, not similar, but the topics are similar, but the content is different. I think we use different books and examples.
Yeah, there is less stable there.
Yeah, but for blockchain, we haven't have any at the moment, and I think we will try to create a new one based on this.
So, can I ask then? Is in the, do you teach undergraduate already? For example, software-defined networks?
Oh no. For the distributed systems, there are two topics that are not part of them.
Okay.
Software-defined network and CDN, but the
Because
CDN
this is standard, absolutely not standard.
SDN is, I think before we were planning to put it more into cloud computing topics, but we haven't have any materials for that at the moment.
Yeah, because if this is for the students, since I've given a lecture on software-defined networks, students find it quite complicated. Software-defined.
Yes.
It's already network is already complicated, and software-defined network try to understand what is the step and what's really happening and how it works with OpenFlow, for example. Yeah, that's absolutely not an easy step. And why it's better is even more complicated. They would say, yeah, but why don't we use just standard network? Why do we have to go to this?
But when you say 3 credits, it's how many hours? Hours actually for all these 3 units.
So this will be, I think. Let me check it. I have it here. I think it will be 20 hours of lesson because we have a different system, European and the Asian system, but we have done some kind of conversion for this. So I have it here. I can share also with you. So that will be, I share you a moment of what will be the layout of the lesson, like we decided before we made the slides. So let's share this with you in 1 second. Oh, I don't see where is it. Okay, I have to stop this and share something else. Okay. So this is the division in terms of lesson of the same material. So in total, that would be 33. So it's a 33-hour lesson and 12 hours labs. So it's 45 in total. But as I say, it's not easy, especially, for example, as I say, the security there is just 1 slide, and you have also to introduce probably the material, the exercise. Yeah, that's a lot. In red, what you see in red here is the material which is not present, but which was originally described in the structure of the course. But it was a bit strange because this was implying that we should have a lab section already at the level of distributed system, while in the other, in the description of the course, there was written explicitly not to use lab section for this. So there was a bit of inconsistency between the two different versions. I do not know exactly who did this file.
So in this case, 1 lesson is 1 hour.
So 1 lesson is 1 hour, yes.
Lot of info, lot of topics.
It's not going to work. I can tell you already. I mean, if we go, I think there are some lectures which are very large, like synchronization. This is not going to work that you have in 1 hour, or even distributed file system. If one wants to understand, you don't have to rush in these things. You have to give also the time to digest to the students. You cannot just go slide by slide, one after the other. No. So to my view, this is a very optimistic view, which is only for the blockchain. It takes more time. You see, some lectures are dedicated 2 hours for those things. And that's why I suggested that there is a big chance that you have to reduce things. Yeah. So, for example, this lecture here, and maybe also the software-defined network, could be avoided, and also the security could be avoided. And yeah, Kat, I know maybe consensus, we can leave consensus, but not to put too much on it. That's so all this lesson 14 and 15, I could put another column maybe, just to say that this lecture could be easily removed without any problem. And this one also, I think that what is important is security in general is important, absolutely an important topic, but it can also take one course on itself to be security. That's and the question is if in a course in artificial intelligence should be also present things like security. So this already reduced quite a lot, the course, but still it's some of the lectures, one has to teach and see. That's it's hard to say now if you really can manage all this material in one course. I think the main idea is it depends also from where your students are coming from. Like you say, if your students already have this material at the bachelor level, then this can be really done. All this lecture can just be more collected together as a kind of recap, and having a couple of lectures, 3-4 lectures at most, on making a recap for this, and then just concentrating on the cloud computing or on the blockchain part, which will be the new part. So it really depends how the situation is. That for me, it's impossible to say now.
Okay, I think we can adapt.
Yeah, and then more, yeah, sure, absolutely. And then if you say, look, we are more interested in the blockchain, then I would say just do blockchain for distributed system, and then the content is blockchain, and then just maybe a little bit of cloud computing. In Leiden, our course, we do distributed system. It's also a bachelor course, but cloud computing is a master course, which is combined with the high performance computing. So how to program on supercomputers and cloud computing. That we put together these two things. And blockchain is an apart course. It's completely apart.
Okay.
Any suggestions?
I don't know much about blockchain. I have to.
No.
Yeah, but it is interesting.
So I will correct the names. So again, I have to remember this. I will do immediately, otherwise forget. So please, Rosnal, you had
yeah, Marcelo. Yeah, I was thinking like, so it means there's a large flexibility within this course, right? So because
absolutely,
if you can't cover the whole content, for example, if you take even the security itself, we can cover with very broad spectrum.
Exactly. Yes.
Yeah.
Yes, and that I think is the idea of in general of all this training that we are doing. We present the slides, but you have to customize the slides according to your own as a teacher or as a university. You have to customize with what is expected by the students. You know what your student knows already, and of course you can just change things as much as you want. That's the idea. It's more just a guideline. What could be a course on this? And these are well, of course the book of Tannenbaum is a kind of standard book that's everyone uses it. So there is a lot of material around. So it's the only new things indeed is more on this other part, on the content and the software defined networks side. Well, I think that I will just change these names, and I think that's for me, we can also conclude here the session. We don't have it's just a small session. That's fine.
I think for me,
That's the
it's
last
clear.
round.
Just
Is there any?
from the materials, I think the topics are clear. We have just to study them and adapt them
Yeah, sure.
to our courses. Yeah. Is there
Yeah.
any references for the blockchain? I mean, the textbooks used, or
Yes. And let me take it 1 second. For the blockchain, oh no, indeed. I say yes too early. No, there is not. Sorry about that. So no, there is only the reference. They are used. They are only the cloud computing, the book of Raphael's, and then programming massively parallel processor, but this is more on distributed computing and the also distributed computing algorithms and principle, and the Tannenbaum book, of course. So no, not there is nothing there. So that's there are some documentation on containers, for example, on Dockers, and we have some documentation also on Kubernetes, for example, but that's all. So no, there is.
It's fine. Okay.
Okay. I think we can. You can still join the computational linguistics if you want. I don't know if they are still working there. And otherwise, okay, we see tomorrow. Thanks, everybody.
Okay. Thank you.
Thank you,
Thank
Marcello.
you. Thank you.
Bye.